Hello and welcome to the Getting Started with the MSP430 LaunchPad workshop. I'm Scott Bland, author of this workshop and member of the technical training organization at Texas Instruments. This video of the workshop will step you through the presentation and labs so that you can come up to speed quickly on the MSP430 Value Line Series processors and the LaunchPad development board. If you haven't done so already, visit the wiki site address shown below for a complete list of parts needed for the workshop, as well as the workbook PDF and PowerPoint slides. In the first section of the workbook, let's take a look at the value line parts and how they fit into TI's embedded processing portfolio. TI's embedded processing portfolio encompasses a wide range of embedded processors, from microcontrollers to ARM-based processors to digital signal processors. On the microcontroller side, we offer the 16-bit ultra-low power microcontrollers of the MSP430 family and the 32-bit real-time microcontrollers in the C2000, Delfino, and Piccolo parts. ARM-based processors include the 32-bit ARM Cortex-M3 microcontrollers in the Stellaris line, the ARM Cortex-A8 microprocessors in the Citara line, and it also encompasses the OMAP parts, which incorporate a C6000 and an ARM part in the OMAP devices. On the DSP side, we offer the C6000 DaVinci, as well as multi-core DSPs with up to 24 billion multiply accumulates per second. On the MSP430 side, where we're working today, we have speeds up to 25 megahertz, flash memory from 1K to 256K, a wide range of different peripherals on the devices to allow you good connectivity. We see people using these parts in measurement, in sensing, and general purpose, any place that having good analog I/O, good communications, and low power is important. With prices ranging from 25 cents to $9, there are a wide range of applications that these devices can fit in. You'll also notice down at the bottom the software and development tools with Code Composer Studio reach across the entire line of devices. Once you're working with Code Composer Studio, there's no need to get out of that to work with any of the TI embedded processors. The MSP430 roadmap includes a wide range of parts, from the 1XX catalog parts at 8 MIPS, very low cost, the 2XX catalog parts, very low cost in the 16 MIPS range, the 4XX, which includes LCD controllers on board, the new 5XX and 6XX devices, highest speed and the lowest microamp per MIPS rating at around 160. The 6XX will now have LCD controllers on them. These parts are targeted to include FRAM, some of the newest memory on the devices, USB, as well as RF. The parts that we're interested in down here on the bottom are the value series devices, the G2XX1, which is what we're using right now, and newer devices that are in the pipeline that'll provide you with a little bit more capability without a whole lot of extra price. TI's portfolio of MSP430 value line parts currently includes these 9 devices, with program memory up to 2 kilobytes, SRAM of 128 bytes, 10 bits of general purpose I/O. All of them have a 16-bit timer. All of them have a watchdog. All of them have the brownout reset circuitry on board. A certain number of them have the universal serial interface on board, which does I2C and SPI. 2 of them have the comparator. 2 of them have the temperature sensor on board. And 2 of them have the ADC, which has 8 channels and 10 bits, with prices ranging from 52 cents all the way down to 34 cents. On all these devices, if you run the parts at 2.2 volts, your power consumption in order to retain the RAM, 0.1 microamps. In standby mode with the VLO running, it's 0.4 microamps. In real-time clock mode, so that you can actually keep time on the part, 0.7 microamps. If you're running full speed, it's 220 microamps per MIP active current. When you go into standby modes, one of the primary things you want to know in order to take care of real-time activities is how fast you can wake up. This device can wake up in less than 1 microsecond. The CPU that's utilized on the value line parts is 100% code compatible with all earlier versions. The device has a 1 megabyte unified memory map. There's no paging required. Extended addressing modes are capable with a page-free reach of 20 bits. That offers you improved code density and very fast execution. We have full tool support through both IAR and Code Composer Studio. You'll notice that we have a 16-bit normal address reach with a 4-bit extension, giving you a full 20-bit reach. It's a 16-bit data bus. There is the R1 stack pointer, R0 the program counter, R2 and R3 are specialized registers, but then R4, 5, 6, 7, all the way up through 15 are general purpose registers. This makes the MSP430 CPU very C code compatible and C code friendly. The memory map on the value line parts shares a lot in common with every other device in the portfolio, as well as other MSP430 devices. In this case, I'm showing the 2231 memory map. Starting at the top, there's the interrupt vector table. Just below that is your flash and ROM. Just below that, you'll notice that 010FF to 01000 is the information memory. That's where we'll find some of the calibration constants stored, as well as some other areas that are available for you to use. The RAM is then below that at 27F to 200. The 16-bit peripherals are mapped from 1FF to 100, 8-bit peripherals from FF to 10, and any 8-bit special function registers all the way at the bottom of the memory there from 0 to F. This memory is the flash in this part is programmable either via JTAG or it can be programmed in system. It's in system programmable as long as you have the voltage 2.2 volts or higher. You can program single bytes or words. The in system programmability in Erase is interruptible if you like. The main memory in here, the segments are 512 bytes. Depending on how large the memory is. In this case, we have 2 kilobytes in the 2231 and the rest of the existing value line parts, so you have 4 segments inside there. You can erase individual segments or you can erase all of them. The information memory in this device is 64 bytes. There are 64 byte segments, 4 of them A to D. Section A contains those device-specific calibration data like on the DCO, and each one of those sections is lockable. There is a programmable flash memory timing generator, so if you're changing the speeds of either of your clock or you're changing the voltage, you can change the timing generator to match that. Taking a little closer look at the value line peripherals, there are 10 bits of general purpose I/O on the device. 8 bits are available on port P1, and there are 2 ports on port P2. Each one of those GPIO is independently programmable, and you can have any combination of input, output, or interrupt, and the edges are selectable, is possible on those. You have read-write access to the port control registers in all of your instructions. You don't have to utilize a special instruction to do that. And each I/O has its own individually programmable pull-up or pull-down resistor if you need to use it. There's also a 16-bit timer, timer A2. It has 2 capture and compare registers available and extensive interrupt capabilities. We'll be using those in the labs. The WDT Plus Watchdog timer is an enhanced watchdog timer on this series of parts. You can use it as a watchdog timer. It's also available to be used as an interval timer, and we'll do that in the labs. The brownout reset circuitry provides you with your correct reset signal during power up and down, regardless of the ramp of the up or down. And that power consumption for that circuitry is included in the baseline current draw. There's nothing extra that we say that the CPU is this and the brownout is this. No, the whole thing is together. The brownout reset circuitry is included in all of the current consumption calculations. The rest of the value line peripherals include the Universal Serial Interface. This portion provides basic hardware support for SPI and I2C implementations, as well as master and slave modes on those protocols. It also offers you programmable clocks so that you can feel free to move the CPU clock around pretty aggressively. Some of the parts also have a upgraded comparator a comparator to provide you with, it has inverting and non-inverting inputs. There is a selectable RC filter output. There's also a output to the timer A2 capture input for additional flexibility. And of course the comparator has interrupt capability to interrupt your code when the comparator goes off. Some of the parts have a 8-channel, 10-bit, 200 kilosample per second successive approximation A to D converter. These two devices currently have 8 external channels. Of course, that's device dependent on how many of the 8 come out. Voltage and internal temperature sensors on those on 2 of those inputs. There is a programmable reference. The A to D converter circuitry has a direct transfer controller that will send the results to a conversion memory without CPU intervention. So once you've programmed it to do the conversion and do the sampling, it will do that without your intervention. When it's done, it can then interrupt you. It can interrupt you on multiple transfers, a single transfer, basically anything that you program it to do inside the ADC circuitry. It's a very flexible and very low power addition to the MSP430 CPU. The LaunchPad development board is a simple, low-cost way of getting up to speed with the MSP430 value line parts. You'll notice up at the top here is a USB emulation connector and the embedded emulation on the board. This is one of the first MSP430 boards to include embedded emulation, and it does not require the normal JTAG interface that we've needed in the past. There's a 6-pin EZ430 connector. This corresponds to the EZ430 protocol that we use on a number of the other boards. The VCC is here. We're going to be using this later on in the workshop and in Lab 6. Also the transmit, receive, the reset, and the test pins for the JTAG connection. In the kit, you'll notice that there's included a microcrystal that you can solder onto this point. If you want to use the GPIO for other purposes, you may not want to have the crystal on there. For flexibility, the designers decided not to have it soldered on the board. The board has the 2231 already placed in the socket. There's another device that's included in the kit. The power connector is down here should you want to use a different power than having the USB emulation provide the input power. The reset button is here. The LEDs are here, red and green, along with jumpers that you can disconnect those and connect them to something else. The main interface with the software is through this port 1 pin 3 button right here, and all of the I/O comes out on this strip right here, so you can access it if you like.